Chemical and physical properties of acids and bases. Acids were first recognized as a class of substances that tasted sour. Vinegar tastes sour because it is a dilute solution of acetic acid, CH3COOH. The hydrogen atoms in acetic acid are responsible for its acidity. Many fruits are sour because they contain citric acid. Bases, also called alkalis, are characterized by their slippery feel. An example of a base is sodium hydroxide. In contrast to acids, many bases contain hydroxide groups, that's OH-. And right here, we're going to define what that is on the next slide, that OH-. An everyday example of a base is Drano. This is a concentrated solution of sodium hydroxide and is used to unclog drains. Extreme caution should be used when using Drano because it is a concentrated base. Ions are atoms or groups of atoms, like on the previous slide where we had OH-, that have become charged by either gaining or losing electrons. Cations are positive and are formed by elements on the left side of the periodic table, the metals. And you can see hopefully here H+, magnesium 2+, etc. Anions are negative and are formed by elements on the right side of the periodic table, the nonmetals. So H-, O2-, etc. For example, sodium will lose one electron to become sodium plus the electron. The plus symbol in sodium plus indicates 1 unit of positive charge. Another example, magnesium will lose 2 electrons to become magnesium 2+. And there's the equation for that. The 2+ symbol in magnesium 2+ indicates 2 units of positive charge. Group 15 anions always have a charge of 3-. Group 16 always have a charge of 2-. And finally, group 17 anions always have a charge of -1. The group 15 elements gain 3 electrons, becoming anions with a charge of 3-. Many cations, including all of these, have the same name as their original neutral atom. So we'll just take one example here. Magnesium 2+ is a magnesium ion. And if you'd like, you can pause this video and look at the other elements. The names of monoatomic, that means one atom, anions are almost the same as that of their original neutral atom, but end in "ide." The ions produced from group 17 elements are also called halide ions. So here, this is oxygen, and its ion form is called an oxide. Sulfur 2- is called sulfide. Iodide is iodine 1-. A polyatomic ion is a group of atoms that are bonded together, have a net charge, and act like a single unit or ion. They are bound to other ions and are not found free in nature. Here are some common examples. And here's the one that we let everything off with, the hydroxide ion, OH-. The charge of the total polyatomic ion is shown outside the parentheses. This shows that the sulfate ion has a net charge of -2. The ratio of charges in the ion are shown in subscripts, that's right here, the 4, but 1 is not written, it is implied, so there's 1 sulfur atom, but you don't have to put a 1 there. This shows that a single sulfate polyatomic ion has 1 sulfur atom and 4 oxygen atoms. Acids are substances that contain hydrogen atoms. The acid is able to donate a proton to another substance. Bases are substances that can accept a proton and can donate a hydroxide group, OH-, to another substance. Acids can react with metals to release hydrogen gas. Bases can react with oils and fats. They react with each other, acids and bases, to form a salt and water. When they are dissolved in water, they can conduct electricity. Dissociation is when a molecule or compound separates into its smaller parts. Acids and bases start out with a 0 charge. They are neutral. When placed in water, they can dissociate into positively and negatively charged ions, enabling them to conduct electricity. pH is a measurement of how acidic or basic is a substance. Acids have a low pH and bases have a high pH. This measurement will be discussed later in the unit. Physical properties of acids and bases. We have taste, smell, texture, and pH. An acid is sour, and it can burn your nose, so you really shouldn't try to smell it. It's sticky, and its pH is low. Bases are bitter. They have no smell except for ammonia. They are slippery, and they have a high pH. Common household acids are vinegar, acetic acid, and citrus fruits, citric acids. Common household bases are soaps and bleach, ammonia, and baking soda. Strong acids completely dissociate in water. For example, hydrochloric acid dissociates into H+ and Cl- ions. So hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid, and perchloric acid. Weak acids do not completely dissociate in water. Some of the molecules produce positively and negatively charged ions. And here's your common weak acids: phosphoric acid, hydrofluoric, hydrocyanic, carbonic, and acetic acid. All strong bases are a group of compounds called metal hydroxides and completely dissociate in water. All alkaline metals in group 1 form hydroxides that are strong bases: lithium hydroxide, sodium hydroxide, potassium hydroxide, etc. Only the heavier alkaline earth metals in group 2 form strong bases: calcium hydroxide, strontium hydroxide, and barium hydroxide. Weak bases only partially dissociate in water: cyanide ion, fluoride ion, acetate ion, and ammonia. When acids and bases react, one of the products is a salt. So here's some common examples: table salt, calcium chloride, magnesium sulfate, and sodium bicarbonate.